All right, so welcome to this session. This session is called Java 17 Deep Dive. It's not such a deep dive because even 3 hours, even if it's a long session, 3 hours is not that much to cover everything that is new in Java 17, especially considering the fact that you're probably not just interested about what happened between 16 and 17, neither 15 and 17. Who's still running Java 7? Oh, come on. All right, there are 2 people here. Anyone can help them in the room? Explain them that, yes, Java 7 is really something that is 10 years old. And, you know, in computer science, 10 years is several lifetimes. OK, sorry about that. I'm sorry. I feel sorry for you. I'll just try to explain you everything that you're losing by staying on Java 7. Java 8? Yes, that's the majority of you all. Java 11, I guess? Yes, that's about half, 8, 11. And 17? No one. OK, that's fine. It has been released just 6 weeks ago, so it's not too bad. We're going to talk about that, and I would like to talk about mostly about what you have in 17 when you're coming from 11 or 8. So it will talk to most of the people in this room, to most of you, I hope. And I would like to focus on the code. I would like to. Who in the room doesn't define him or herself as a developer? No one. OK, great. This is exactly the. I love you. I already love you. This is all I want to tell you. All right. So my name is José. OK, I joined the Java platform group just 6 months ago. I used to work at a university in Paris. I just pushed here some links with the content I publish on the internet. So if you're interested in any kind of thing, the most recent one being the JPackage. It's the 3rd YouTube link. If you just use this link, you will see short 10 minutes videos focusing on one single aspect of the language between 8 and 17. So some things are really new, some other things are a little older. We are organizing an unconference called the JShell.org, and we are partnering with JAlba, which is another unconference organized by Maurice Naftalin from Edinburgh. Maybe you know Maurice. It will be online only. Hopefully we'll be able to go back to in-person and conferences in the months to come, but we can't be sure yet. So if you're interested in that, if you're just curious, if you don't know what an unconference is, you're really missing something really great. So I encourage you to check this link or the JAlba website where you will find all the details. And I would like to focus also on something else, a website called dev.java. Maybe you've already heard about it, maybe you didn't. It's a website that was released at the same time as the JDK 17, so back in mid-September, which is a website created by the developer relations team, that is my team at Oracle, and that gathers all the information, the documentation, the tutorial, everything you need to know about the Java, the language, the platform, how to install it, what version you need, this kind of thing. And there are many, many tutorials here behind this website. So if you can just check this out if you're interested. This is a great resource for documentation, I would say. All right, so unless you've been living in a cave for the past few weeks, you already know that Java 17 has been released. And this Pac-Man-like slide is just here to show you the current share of Java 8 and the current share of Java 11. This is kind of statistics you can find everywhere on the internet. Basically, currently, there are 2 versions of Java that are being used, Java 8 and Java 11. Sorry for the Java 7 guys, but you're such an endangered species that they don't even appear in the statistics anymore. And if I didn't ask the question, but if you're on a version even older than Java 7, you're in even a bigger trouble about that. So I just would like to take a few minutes to talk about what is an LTS version, because there are lots of confusion about that. Why are the Java 8 and Java 11 version the most used? Because they are LTS versions. The answer is very, very short. And why are you interested in Java 17? Because it's an LTS version. And why nobody is on Java 15 or Java 16? Because it's not an LTS version. So what's an LTS version? The first thing you need to understand is that the Java platform and Java source code is developed, is written under the umbrella of the Open JDK, right? This is the link to their website. And the Open JDK is a place to collaborate, blah, blah, blah. Okay? It's a place. The important word is that the Open JDK is a place. It's a house. So you cannot download the Open JDK. It doesn't make any sense. If someone is telling you, oh, you should be using the Open JDK, no, you can't. Because it's not code. It's a place where people are working and where people are thinking about how, what Java should be, right? The Open JDK hosts a bunch of source code on a GitHub account. It used to be on a Mercurial account, hosted by the Open JDK website itself, and it has been moved to GitHub. I can't remember when exactly. I think it was a year ago, about something like that. There was a special Open JDK project to do that, which was called the SCARA project. If you want to have the details about it, you need to search for the SCARA project on the Open JDK website. So now if you want to download the source code produced by the Open JDK, which is the source code of the JDK, you can do that. You just need to clone this GitHub repository or download it, and it works perfectly well. And by the way, on the JDK project, you have a README explaining you how to build your JDK, the source code you want to download. There are instructions on how to build it, so you can do that. It takes time, and it takes some resources and some places on your hard drive, but you can still do it. And by the way, there are other branches. You see the other repositories, sorry. You can see the Loom, Ember, or Valhalla repositories, which are projects within the JDK, within the Open JDK, sorry. And the Ember project, we are going to talk about that in more details in roughly the second half of this presentation. Okay, so what does the Open JDK do? The Open JDK is making code, all right? And since the Java 11 release, which is here, this code has a lifespan of 6 months, okay? Can you tell which LTS version is on the source code? Well, no, you can't. Because the LTS, this LTS notion is not a source code notion, okay? This is 11, 12, 13, and every 6 months, the code is moved from one label to the other, all right? And some of these versions are going to be handled, patched, and some others are not, okay? But from the source code perspective, this is what is happening in the house of the Open JDK, okay? If you check the tags of the current JDK repository, you can see that we already have 21 tags for Java 18, which is going to be released next March. Okay, so the work on Java 18 has started right after Java 17 was released as a general availability. What is happening when, after this first 6 months, after a release has been done? For instance, after the first 6 months of the release of Java 11, okay, what is happening is that there is a call to volunteer who is up to handle the previous version of the JDK, and sometimes people show up and sometimes they don't. So if you check that, you can see that the light gray bars are the patches that have been published on the 11 repository, for instance, by people that are not from the core team of the JDK 11, because the core team is now working on the JDK 12 project, okay? And you see that for some versions, there are people that are continuing providing patches and maybe backports and this kind of thing, and some other versions are just dead. They do not exist anymore. So this is still a source code version. I'm just talking about source code. I'm not talking about distributions whatsoever. The bar at the bottom is the Java 7 bar. Okay, so there were patches for Java 7. That's good news for you. Up until February 2021. That's roughly 7 months ago. Now, yes, I see someone is half laughing. I guess it's a nervous laugh, is it? So please move, do something. The other bar just on top of it is the Java 8 bar. So there are still patches on the Java 8 source code branch, all right? And the other, you can see that the 11s, the 13s, and the 15s are being handled by people, by volunteers from other companies. And there's no one on the 17th, and hopefully there will be somebody showing up for the 17th. We'll see that. But this is still the source code. Now, what you want to download to have your application working is not the source code, of course. It's a distribution with binaries, and hopefully working binaries. So you can build that yourself, but guaranteeing that what you're going to build is good enough to run your application in a production environment might not be the best idea. So maybe you will rely on someone who will provide you support and this kind of thing. And here you have several possibilities. People would say many possibilities, but you have several possibilities. I'm going just to talk to you about the Oracle one. Okay, Oracle is providing distribution which is called the Oracle Open JDK for 6 months for free, downloadable from the Open JDK website, and it is a build of the JDK source code that you can download on the GitHub repository, and this is free for any kind of application, etc. And up to the 11th version, after that, you had to pay if you wanted to use that JDK built by Oracle in a production environment. It was not a free download. Well, you can download it as long as you just want to test it or study this kind of thing. But if you want to use it to run your application in a production environment, then you have to pay a license. This was the situation up to the release of the JDK 17. Now, there are two things that changed. The first thing is that we had one LTS every 3 years. So LTS distributions, and I'm not talking about LTS versions, but distributions, are 11, 17, and 23. The plan was to have the 23 version to be the next LTS release. That is in 3 years from now. Okay? So the first change, and it's still a proposed change, is that the next LTS revision will be the version 21 in 2 years. Which is, I think, for developers, a good news, because since we are moving from one LTS to the other, it means that everything that I'm going to talk to you about, all the new shiny things that you are going to want to use, you will be able to use them in either just now, either in 2 years instead of 3 years. All right? So from my point of view, it's a good thing. Maybe you may have a different point of view, of course. And the second thing that is moving is that what you used to pay for, what you had to pay for, is now going to be free. That is, the Oracle JDK is going to be free even for production environment for the next 3 years. So the JDK 17 Oracle JDK will be free for production environment for the next 3 years. Why is that? The idea is that you will be able, you have a 1 year time frame to move from 17 to 21 without changing the license. Okay, so if you want to do that, you will be able to do that. Why has it been done like that? I just put you 2 links. One from a blog post that Mark Reinold wrote, where he explained that, in fact, when JDK 11 was released, there was it was kind of a challenge to say, okay, are we going to be able to release a JDK every 6 months? Is the ecosystem will be able to cope with that? The IDEs, all the third-party dependencies that we use for our applications, are they going to be able to handle this pace of releases? And the answer is yes, in fact. The ecosystem could handle that, can handle that now. So moving from a 3 years release cadence to a 2 years release cadence seems to be doable. Now, it is still a project. It's a proposal. It should be accepted, but it has not been accepted yet. So, but that's the plan. That's the plan. And the second point is that yes, we will be able to get the new features of Java, of the JDK, faster with such a release, because we are moving from one LTS to the other. The last thing, so the license becomes free, and the other thing is well, it is a big deal, but it sounds almost funny, is that you will not have to click that you accept the license anymore on the page, all right? And if you're using a Jenkins or SDK man or a Docker or whatever, the kind of thing that, of course, nobody uses these days, well, you will be able to download the JDK directly from a stable URL without having to click. This is the no click-through stuff, all right? So the stuff that is downloading the JDK may not have a finger to click on the link. So there is no link to click now anymore, which is great. All right. As for the license stuff, I just would like to give a word of warning. The license stuff is the stuff for lawyers, okay? I'm not a lawyer. Maybe there are people that know law very well in the audience. It's not my case. But this license stuff should be really dealt with lawyers. So if you have lawyers in your company, they are the ones that are able to tell, yes, we can use this free license or not. All right. I just wanted to show you one last thing relating to the JDK is the number of new features we have between 8 and 11 and between 11 and 17. Just to show, because we have now this 6-month release cadence, you just check the new feature from one release to the other, and you can see that there are like between 6, 8, and 10, 12 new features every time. And say, okay, but on the overall, how much is it? And you can see that, in fact, the number of new features from one LTS to the other with the 3 years release cadence hasn't slowed down. So we have I don't know how to say it, but really Java is just moving forward at the same pace as it used to be, starting with Java 8, which is of course very good news. And there are extraordinary things that are going to show up in the language, starting with 17, that I'm going to show you that is going to be a real revolution for the language, which is called pattern matching, and we are going to spend a lot of time talking about that in this talk. All right, so what are the new features we have in the JDK 17 from 8 to 17? That's the list, okay? It's not everything is here, but I would say the main things are here. I'm not going to cover everything. I just would like to focus on several points from this list, because it's not a catalog. It would be quite boring to just, oh yes, we are going to take about this, and then this, and then this. So I'm going to make it as lively as possible. But we're going to cover, for me, the most important and the most interesting things that you have as a developer. Okay, and we'll end up with the language, and in the language part, we are going to cover everything, and I'm going to show you example of that on live coding, because it's always better, I think, to see things on real code rather than on slides. Okay, so let us start with the tools. Okay, the tools are this one. I would like to focus on these 3 tools. We never heard about JShell. Gosh, yes, there is 5 to 6 people never heard about JShell. JShell is a Java shell, in fact. It's a shell you can launch, and you can just type in Java code in it, and it will run. And it's just that. But it's really nice to have that. Okay, maybe I'll try to show you JShell a little just to give a flavor of what it is. Great. I would like to focus on the Java source code launcher. We're going to start with this one, and then JDEPs and JPackage, because those are really, really nice features. OK, this is a Hello World class. I guess you know what it is. You recognize Java code, and you know what it is going to do if you type in this kind of code. You know that when you type this kind of code, and I've been giving courses to students who had never had any contact with Java whatsoever. This is quite hard to make this stuff working, because you need to JavaC this. You need to understand that you need to launch the JVM, passing the name of the class and not the name of the file, .class, etc. There are many traps in running this code when you're really a complete beginner. And we now have the possibility to just type in this command, Java hello world.java, and it's going to run this class. Compile it, launch the JVM, pass the name of the class, and run this class, which is nice. It's a great tool when you need to learn Java, but you're all seasoned Java developers, so you don't really need that. Okay. If you want to have to add third-party dependencies on it, for instance, random utils is something that is coming from Apache Common, right? You just can add your .jar to it, and it will work also. It sounds like magic, but in fact, it's something we could have from the very beginning of Java. But the really nice thing is that you can create this kind of file with it. Okay, they call that the shebang file with the name of the shell. You see, this is very classical in Linux or Unix environments. You just put the reference to the shell that you're using. Now you can just give the Java virtual machine. Okay, the source code is Java 17, could be Java whatever version you need to use, and it will run that as some Java code. So now you can use Java as some kind of a scripting language, I would say. Okay, there are only two restrictions on that. The first one is that the file cannot have the .java extension, so you need to remove that, and the file has to be made runnable. So you need to change mode it to be able to run it, and that's it. And that's it. It's not a super revolution, but it's a nice feature to have if you want to write scripts in Java. Okay, and that's it for this one. Yeah, question. So the question is about the dependencies. If you have third-party dependencies, to be honest, I didn't try that, but I suspect that you can pass the -cp stuff to it, and it should work. You need to try it. I didn't try it, to be honest. Okay, but if you want to have several classes, let me go back to here. If you have more than one class, you can put more classes in this file, right? You have one public class per file, but you can add other classes if you need. It's still a script. You cannot launch a whole application with that. But if you have just some source code to run, you can do it. Yes? Other question? Sorry? Sorry, I didn't hear you.
You mess it up when you're writing the code.
Yeah?
Give you the compiler errors.
You will have you need to debug that before you do it, but you'll have exceptions. If you have compile time errors or runtime errors, you will have the exceptions that are going to show up. Okay. You need to try that yourself. It's a great feature, to be honest. I'm super happy to have it. I use it, in fact, because I'm not that good at Perl or JShell and this kind of stuff. I'm better at Java, so I like to write my scripts in Java. And now I can, so I'm happy. All right. The next tool I would like to show you is called Jlink. You have already heard about Jlink? Yeah, some of you, not many. So you know that starting with Java 9, Java IC 9, there is this module system that has been added to the distribution. Now, modules is something that is not very well known, and many people are not using it. But if your job is to create images with Java runtime, and you're not happy because the old JDK is close to 300 megabytes, which is quite a lot. And you would like to have a smaller runtime because your application is only doing very basic things, and you don't need the swing packages, and you don't need the SQL packages or the IO packages, all these things that are taking a lot of space on your hard drive. Then what you do is, what you can do is modularize your application, and this is quite easy because, in fact, if you have a very simple application in one, let's say, Maven artifact, all you need to create is a module info.java file that your IDE can create automatically for you. And then you can use Jlink to create a runtime that is tailored for your application with only the modules needed for your application. So it can be much smaller than the old JDK. And the basic command to run that is to use the Jlink. Jlink is a tool that you have in the JDK distribution, right? It's in the Java Bean distribution. And you just have three options to give to it to run it. And it will create a directory with everything, with the runtime environment, with the Java runtime environment, but with only the modules that you need. Okay, so instead of having all the modules of the JDK, you will have only the modules that you need. So that's the Jlink, the gist behind the Jlink tool. So for instance, if you run this Jlink, and you only need, this is the Jlink for your application, and if you want to launch your application automatically with this distribution, you can. You see, I'm just going to add this option, launcher, telling, hey, this is the main class. The main method is in this class, and this is what you need to launch the app. So in this runtime, you have the modules of the JDK you need, the modules of your app, and a special script to launch your app using this runtime. So you just need to run this command line at the end of the day to run your application. And if you check the size of the files, the smallest runtime environment that you can create is this one. You just need to add the java.base module, which is the module with the core language and the core APIs, the string class, this kind of thing, right, the object class. And you just output it to your own runtime environment. And you will see that the runtime environment is down to 40 megabytes. Compared to the almost 300 megabytes of the full JDK. So you have a runtime that is much, much smaller because you've stripped everything that you don't need. Okay? So to these 40 megabytes, you need to add the files, the modules of your application that are going to add to that. But it will give you a much smaller image. Now, if you want to go even further, there are more options to this Jlink tool, allowing you to compress the modules to make this image even smaller. But after that, to run it, you will need to decompress it. And if you decompress it, it's computing time versus disk space. So, yeah, question?
So, when we're running like the CI pipeline, someone's made some commits, they've made some changes, would I need to introduce that into the pipeline to rebuild the dependencies every time?
If you are building an application and want to use that, you can introduce that in your CI/CD pipeline. The question is about, I'm just repeating the question for the recording, sorry. The question is about the CI/CD pipeline and how you can introduce that, how you can integrate that in your CI/CD pipeline. Is it okay?
It's kind of like, am I going to need to run that every time? Because someone's made a commit, they've introduced kind of a new library. I'm going to need to rebuild the Jlink packaging stuff.
Yeah. Yeah, if you change the module stuff, you need to rebuild your Jlink stuff, absolutely. But this Jlink stuff is just a matter of copying the right module from one place to another. Okay, so you need some disk space to do that because you have to store the JDK and then to store your new image. All right, but it's not a very from a computation point of view. It's not like a compilation, for instance. It's much lighter. And much faster. It's not as heavy as a computation. Because all the modules and all your modules will declare the dependencies in this module info.java file. So it's just a matter, Jlink, I don't think that Jlink needs more information than what is stored in this module -info.java files. So this is all it needs. And after that, it's just a matter of moving files and jar files from one place to another. Okay, that was for Jlink. So Jlink is for building, I would say, optimized images with only the modules from the JDK you need for your application. If you don't need Swing, you will not have the Swing module in this runtime environment, for instance. Swing is the best tool because when you're writing a server-side application, you don't need Swing. But if you're having the JDK, you have the Swing packages in it. All right. Now, there is another tool called JPackage. Okay? And JPackage, sometimes there is a confusion between Jlink and JPackage. So Jlink is to create images tailored for your application. JPackage is made for creating installers. When you need to create an installer that people are going to use to install your application on their machine. All right? If you're working on a Mac or on a Windows machine, and I guess most of you are, when you need to install a new application, what you're installing is, what you're downloading is an installer with everything in it, and you're just installing your application in your machine. And you're running this installer to do that. Well, JPackage allows you to do that, so it's going to package both a runtime and your application file, and it will install that on your machine. And it works on Windows, macOS, and Linux. Okay, and just put all the kind of files that are supported by JPackage. Okay, JPackage is a little more technical to set up and to run because you have more options. Some options are obviously specific to an installation. For instance, here with WinDirChooser, WinConsole, and WinShortcut, those options are for a window installer. They will not work for Linux or a macOS installer, of course. But it kind of works the same. But the goal is not the same, all right? Of course, you could say, oh, but in JPackage, I have an image of my application. And you can, yes, indeed, you can have JPackage to run on an image of your application created by Jlink. They can work together. But the goal is different. Okay? Now, I showed you the link to the JPCafe YouTube videos I record. And there is a JPCafe about JPackage. So there is a 10-minute presentation with several examples on Windows. And the code is on my GitHub repository. So if you want to learn more, you can check that out. You will have all the details on it. JPackage will create an installer, which is basically one file. And if you install this file, you will get this kind of thing on a Windows machine. So that's for the application I set up as an example in the JPCafe video I was talking to you about. It's called the Duke displayer. So those are the directories you will have in your program file directory on a Windows machine if you run the install there. There are many options that you can run with JPackage, including special option you need to pass to the JVM to run this application. You can really tailor things very precisely. So it's really a great tool. Okay, who heard about JPackage before? That's very few people. But it's a great tool. I really love it. And that's for the tooling. Any question about what we saw there? There is one constraint about Jlink JPackage, is that you cannot cross-compile stuff. That is, if you want to create an installer for a Windows machine, you need to run that on a Windows machine. You cannot create a Windows installer on a Mac machine, for instance. This is not possible. All right. Well, let's move on to the API. To the API, I would like to talk to you about 4 things. The HTTP client. We have an HTTP client as an API in the JDK. It popped up quite a while ago. And much more recently, we now also have an HTTP server that we can run directly from the JDK. And I'm going to show you. There are also things about collection factories. This will be the last. And Unix domain sockets. And Stackwalker. Yeah, let's dive into that. Yeah, let me do that. So to create an HTTP client, it's a 3-steps process. Okay, the first step is to create a request, and all the API has been designed with this kind of builder stuff in mind, with you see things that you can chain. So it makes, I think it makes the code very easy to read, easy to understand. You have many options in the API. I'm not going to go through all of them. But this is basically how you can create a GET request with the headers and the options and this kind of thing. And now that you have the request, what you need to create is a client. You can have a connect timeout and this kind of thing. You can also put many options in a client. And when you have a request on a client, you can just send the request with the client.send method, pass the request, and pass what they call a body handler. Now you have a bunch of body handlers available through this HTTP response body handlers factory class. You can create your own body handler if you want to do so. But the factory methods already cover many use cases. If you call this method of input stream, then what you get is an HTTP response of input stream with the generic type being parameter type being input stream, okay, from Java IO. And if you call response.body, it will return the T type of the HTTP response of T. So that's a factory method that will give you the body of the response as an input stream, and you can analyze it as such, if this is what you need to do. But if you want to have it as a stream of lines, each line representing one line of the body response, if what you're going is a text file, for instance, you can do that. It's the offlines method, factory method that you will get. All right? And if you want to get to create your own body handler, it's not that hard to do. So if you want to have your own body handler to analyze your response, you can also do that. You see that it changes the type written by this body call. This is how the HTTP client is working. Now, to create a server, what you have an API for that, and I'm going to show it to you. But you can also launch it as a tool, just by calling java.m jdk.http server, and that's it. You can pass many options to it. I just put a few of them. Bind address, directory, which is really interesting. This is a very basic HTTP server that you're launching. You cannot put it in production and serve many pages to many clients. That will not work, obviously. And it will serve the structure of a given directory of your local hard drive. That's the idea behind that. Why would you be interested in that? Well, if you need to test things very quickly with a very simple HTTP server, this would work. You can add handlers on it. You can add filters on it. There are several things that you can do. Okay, this is the API. And by the way, this is JShell. Okay, JShell is just a shell, in fact, and you can pass Java instruction. You can type in Java code in it. It's really great. This is. I'm sorry, I'm not going to read it for you. You can read it yourself. But this is basically the type of code you can type in to launch this HTTP server, and server start will launch the server. So it's really super simple. Well, and that's it for the HTTP server. I didn't have much to say about it. Unix domain sockets. That's also new stuff that has been released not a long time ago, but that's available on Java 17. It's called Unix domain socket, but you can also use it on a Windows machine. Okay, it's not specific to Unix. And the idea is to create. There are people waiting at the door. you can. There are plenty of available seats. Don't. All right. Sorry, where was I? Yeah. So the idea is to create a communication between several processors, several Java processors on your machine, or even several non-Java processors, okay, on your machine, without having to go through the TCP/IP stack. Currently, if you want to do that, you probably will go through TCP/IP, open a port, and communicate through a port. With this kind of socket, all you need to have is an access to a file system, and this file system has to be shared between the two processors you need to create communication between, right? As it is the case here, for instance. And you just create this Unix domain socket address. Okay, this creates an address based on the file of the file system. And this code will be shared by both the client and the server. On the server, you are going to create a server socket channel. Okay, and this is the code. The standard protocol family.unix is the new stuff that you can use to use these Unix domain sockets. All right. And the principle is that you create a server socket channel, and when you call the accept method, it will block. And when there is an incoming request, it will create a socket channel that you can use to communicate with the process on the other side. It's kind of the same as the classical legacy server socket and socket from Java I/O, but this is Java NIO stuff. It's more recent. I wouldn't say that it's new, but it's more recent. And you can also have a non-blocking version of this accept method, because the N from NIO means non-blocking. So obviously, you can be non-blocking in this stuff. And on the client side, what you need to run is socket channel open socket address. And this will give you the socket channel through which you are going to send requests to the server. Now, you can write on the client and read on the client. And of course, the information you're going to move from the client to the server will be read on the server, and the server can answer by writing stuff. Now, this is based on Java NIO, and there is a bridge on this socket channel in Java NIO, which is the socket method. There is a socket method that returns a plain Java IO socket. But in this case, it will not work because it's not supported for this kind of socket channel. So you're really stuck in a Java NIO. And writing and reading stuff using Java NIO is not as easy as it is with Java IO. So it becomes a little technical. The code is not that simple. You need to deal with byte buffers, channels. You can set up selectors on it, even if you wish to do so. So it's not super easy, but performances are great. All right, that's for the Unix domain socket. And I can also cite a video that has been made on this subject by Nicolas Parlock from the Java Developer Relation team at Oracle, called the Java Newscast, that you can find on our YouTube channel also. All right, so that's for the Unix domain socket. And the last stuff I would like to show you is the stackframe worker. What's this stuff? You know what the stackframe is? It's the big stuff you get when your application, when you Spring Boot or Tomcat or whatever application crashes, and you get this huge stack trace of classes, methods with source files and line that are calling each other. Okay, well that's the stackframe. Currently, to get a stack frame, you have two methods: one on the thread class and another one on the throwable class. Did I put them here? Yes, that's the get stack trace method. They are available on the thread class and on the throwable class, and they are quite annoying to call because what is created is the whole stack trace. Okay, and sometimes in your application you only need the class that is calling you, maybe the class before that, or the class before that. It's just the top of the stack. It's not the whole stack itself. But you still need to create the whole stack, and this is quite heavy. It takes memory, it takes time, and it's not necessarily super reliable because this stack can be changed by the JVM with this optimization stuff, etc. So it's not super great. As of now. So the idea is to create an API, and this API has been created, it's now available, of course. The idea is to create an API that is going to take a callback, and that is going to create a stream of stack frame with all the stack frame calling each other. And the nice thing with the stream API is that it's a lazy API. So it does not create the whole stack frame, it should just create it one step at a time. So if at some point you say, okay, I'm going to stop there, then the rest of the stack will not be created. So it will be much less resource intensive as the current state. And the code is this one. To create a stack walker, you need to call this factory method, okay, passing this option. Now this option, here I just used the retain class reference option. It's probably the option you will want to use. You can pass more options. Basically, there are two other options that are going to say, do I need to see the hidden classes? Do I need to see the reflective classes? This kind of thing, okay? And once you've done that, well, you can just use this walker in two ways. You have a for each method, which takes consumer as an argument. It's the same kind of for each method we have on collection, or the one we have on iterable, in fact, because it's defined on iterable, or on map, even if walker is not an iterable. You pass a consumer to it, and then you can do whatever you want. This will walk through all the stack frame. You cannot interrupt it. Okay, it will go all the way from your frame up to the top frame. When you're in a web server, it's usually thread.run. That's the ultimate method that is going to call you. But if you want to be able to interrupt that, you can also do it with this other pattern, which is the walk stuff. And this walk stuff takes a function as a parameter. The function takes the stream, and with this stream, you can do whatever you want, including interrupting it before it reaches the top of the stack, okay? Or the bottom of the stack, I don't know. Well, the first call, the first call on the stack, okay? So here I just took, okay, give me the names of the class. This is the map step, and the filter, because I'm only interested, I'm looking for a specific class in this stack frame, and once I've found it, I need to stop because I need to do something with this class, for instance. So I just call the find first. Now this find first returns an optional, thus the optional string that is returned by the walk method. The walk method will take what your function produces and will return that to you. So if this class is not found, then the optional will be empty. And if this class is found, well, it will not be empty, obviously. Okay? So that's the stack frame. All right. Okay, and we're in the language stuff. And by the way, I forgot to mention the collection.of stuff. So you know what? Do you like slides? Who likes slides? 3 people. Well, that's funny because it's the exact same number as the people who were using Java 7. Could there be a correlation on it? Okay, so let's leave the slides. You know that. It's called an IDE, yeah? This is what you prefer, don't you? I'm not going to repeat that, sorry. Okay, this is a string of character. Can you see it? What is going to happen if I run that? No transition between the slides and the IDE because everyone, including me, is so happy to have that. Well, it's just going to run that. Can I put you here? Yes, I can. I would prefer that. Is it big enough, by the way? Yeah, okay, great. So that's a string of character. And starting, maybe you have heard that, but starting with whatever version, we have a new stuff called the text blocks. You've heard about that, the text blocks? Text blocks is just this. I'm going to add 3 double quotes, end up with 3 double quotes, get a compiler error. It's not because it's not working, it's because after the first 3 double quotes, I need to add a carriage return. And this is working, okay? I just made this string of character a text block, which is still a string of character, by the way. A text block is still an instance of the good old string class that we've been using for 25 years, even if we're still using Java 7. And the nice thing with the text block is that I can add as many carriage returns in it as I want. Where did I put that? It doesn't make sense to have that. Okay. You see, I don't need to escape anything. And these carriage returns are going to be kept in the resulting string. Isn't it great? Don't you love it? Yes, well, I do love it. Now, you may be wondering, what kind of carriage return do I have here? It's always a \n, whatever is encoded in your source file. Okay? Now, what is happening if I'm doing this kind of thing? You see? If I run this code, you can see that the first white spaces I had on my line have been preserved by this mechanism of text blocks. And in fact, the rule is the following. You have two kinds of white spaces on the thing that I've highlighted here. The first kind is what is called incidental white spaces. It's the white spaces that have been added by the IDE for indentation purposes. And the other one is the one I have added myself. And if you check carefully, maybe it's not very easy to see it. You can see that this wonderful IDE has added a green bar here. Everything that is on the left of the green bar is incidental, and it is removed by the compiler for me. And the rest is kept. Okay? I can play with it. That is, if I move this, you will see that the green bar is going to move accordingly. Okay? So in fact, either if you don't want the last the last carriage return, you can just put those closing stuff just here, and in that case, the green bar will be aligned to the leftmost characters you've added to your text block. And if you want to keep that, you can just play with this stuff and remove the last carriage return by hand. All right. The nice thing is that if you add things like that in it, you do not need to escape them. Okay? If I run this code, you will see that the double quotes and the single quotes have been preserved in a text block. So no need to escape the special characters. Now, if you really want to escape them, you can do that. That is, if you have legacy string of characters that are quite complex, and you want to make them text blocks, you do not need to go through every kind of thing and remove the stuff. Okay, those are going to be properly escaped if you want to escape that. So both systems are working in text blocks, which is really great. Okay, if you want to get rid of the terminal, I'm not going to get rid of all of them. For instance, here. I could put it here, by the way. Okay, you can do that, and this is going to remove the terminal carriage returns you have at the end of each line. Okay, this makes it super handy if you want to have, if you have JSON or SQL, if you're working with Java 7, maybe XML stuff in it. You can just copy paste your XML or JSON here, and it will just work out of the box, which is super great. Now, there is a way to preserve the, I would say, the heading white spaces. There is also a way to preserve the trailing white spaces. Sorry, I'm going to align you guys. Yeah. If you put a \s at the end of each line, it will preserve the trailing white spaces. I'm going to show you that. Okay, I'm just going to change that. By the way, I have a new method on the string class, which is called the lines class. And this creates a stream of the lines of this string of characters. And now I can map that, adding, for instance, a pipe character at the beginning of my string, and a pipe character at the end of it. Okay, and I'm going to print out everything. We are going to talk more about the Stream API just in a minute, don't worry, because there is more to be said on it. And if I run this code, oops, it will not run because it doesn't compile, which is, well, still a thing in 2021. Okay, you can see that the trailing white spaces have been preserved by adding this backslashes at the end of each line of my string of characters. Okay, so that's up for the string, the what is called the string blocks. All right, this is something you have in Java 17. It's not a preview feature. Any question? No, it's okay. Yeah. If you want to use variables, you mean what they call string interpolation. Yeah. So text blocks are not working. So the idea is, oh, but if I suppose I have a, I don't know, something like that, int number equal 10, and I would like to do something like, oh, I want to use this number. Okay, this is what you have in mind, don't you? Okay, you can't. So this will just display number with this ugly sign in front of it. Okay, but it's on the work. There is a preview JEP about that. It's not a JEP still, so it's probably the next thing we will see in this enhancement of string of characters. People are working on it. The syntax is not decided yet. The implementation is not decided yet, but this is something that should show up in the future. Yeah, maybe for next year. We'll see that. And when it shows up, you know what? You will have in 2 years instead of 3, which is awesome. Okay. Let us talk about lists. Who doesn't use lists in its application? Everybody uses lists, right? Everybody uses ArrayList, right? No one is using linked list. Yeah? Okay. So I don't need to talk more about it, do I? I don't. Great. Don't use linked list. Who's using linked list? No one. Great. Okay, so here I have 3 lists. An array list. Everybody knows array list. An arrays as list. Ah. Is it the same as the array list, really? And a list.off. Array as list is an old stuff, right? We've been using that for years. List.off is Java SE9. So if you're in Java 8, you don't have that. You will have it if you move to 11 or 17, which is great. Why did I put all these here? Because there are slight differences between them. Array list, obviously, it's a mutable list. I can add stuff in it. This is what I just did. And I can also add, I can also add null values in it. Okay. If I do this kind of thing, you can see that I have a null value here. Okay, so it supports null values. Arrays as list. What is going to happen if I try to add something to it? Can I do that? No, I can't do that. Who thinks that array as list is immutable? No one. Great. I can't add things to arrays as list. Okay, it's not supported. Can't add anything, can't remove anything from it. But I can modify the existing elements that are in it. So if I call replace all and the string to uppercase, for instance, well, I will put the content of these arrays as list to uppercase. So arrays as list should be seen as a wrapper on an array. That's really the gist of it. Okay, you can't add elements to an array once it has been built. You can't remove elements from an array, but you can change the elements in the array. So that's what you can do with the arrays as list. And you can put null values in it. Okay, now I'm not going to call that because if I do, I'll get a null pointer exception, of course. But you can have null values in an arrays as list, even if it's not a good idea. It's not because you can do something that you should do something, right? We all know that. Now this list.off stuff, so it's called convenience factory methods for collections. It has been added in Java SE9. It's still a list, but it's completely immutable. That is, if I try to add something to it, I will get this exception. Unsupported operation exception. Okay. Obviously, if I add something, it will not work. If I do the replace all, it will not work neither. And if I try to add null value in it, you can see that this idea gives me a warning. Hey, you are trying to add a null value, and I think you'll run into a problem if you do that. And indeed, if I try to add a null value to put a null value in a list.off, I have a null pointer exception. So no null values in list.off. Now, it turns out that I have a new factory method added in, well, since. Okay, we'll have that another time. List.copyof. I'm going to take my arraylist from it. Oops. I'm going to remove you. And list.copyof gives me, sorry, var copy of. I'm going to call it copy of 1. It just gives me, it just gives me a copy of the list I have. Where did you put this null pointer exception? Yeah, here, because I'm not very smart. I just forgot to remove it. Okay. So what I get is a copy of the list I passed as an argument, which is expected with a method called copyof, right? This copy is completely immutable. Copyof add 1 will not work. Okay, I get an unsupported operation exception if I do that. I cannot modify the elements in it, neither. Let me just show that to you very quick. Okay, if I do that, I also have an unsupported operation exception. Good, don't do that. And if I have a null value in this array list, I also may run into a problem, because this list.copyof does not support null values. So you need to be a little careful if you do that. Probably if you are not sure about the status, of the list that you pass as an argument, you may use this pattern, which is the remove if pattern. That's the Java 8 pattern, so you can always use it. And pass just object is null. And that is going to remove all the null values from your list. Now if I run this one, it will work as expected. Okay. Now this copyof has an optimization. I'm going to create a second copy of this and passing this list.off as an argument. Now what I'm going to print here is equals and compute the following Boolean, which is ArrayList equal copy of 1. Okay, so I'm just comparing the reference here to see if this copy is really a copy or if it's the same location in memory. And I'm going to do the same, okay, between copy of 2, right? Because list.off is already an immutable list. So it would be useless to try to copy it in another immutable version of itself, right? What I really want is the two references to point to the same place in memory, because it's immutable, I don't need to copy it. And you can see that this is what is happening. If copyof sees that the list it has to copy is not immutable, then it does the copy in an immutable way. And if it sees that this list is already immutable, it does not copy it. So that's great. This is how I want it to work. Question? The question is, does it work for collections unmodifiable lists, the factory methods that you have in the collections factory class? And the answer is no, because if you check the source code of these factory methods within the collections factory class, you will see that there is nothing you can do with it. well, you cannot see that this implementation is indeed immutable. So it's not supported in that case. You really need to have, but starting with Java 9, you do not need the collections.unmodifiable versions of that, especially with this copy of stuff. So the gist is that if you call copy of multiple times on the same reference, copy of, if you nest these calls, even not directly, you will end up with always the same instance very quickly. Any other questions? Yeah?
So now we have these unmodifiable lists all over the code base, but it's still, on its runtime, it's happening runtime. Would it make sense to have a new list interface that is the unmodifiable list then?
So the question is about, would it make sense to have a list, a special list interface to mark that a special implementation is immutable? Yeah. So the quick answer is we don't have that. That's the quick answer. There is a longer answer. You have that in other collection frameworks, like Eclipse collections, for instance, where you have an immutable list type. Now, there are drawbacks to do that. Does the immutable type extends the non-immutable type, or the contrary? Because if there is no relation between both, or if you don't have a super type to cover them all, for instance, your source method, which takes a list as an argument, it should be working on regular lists. It should throw an exception on immutable lists. You see that you have, when you're designing your API, you will run into problems. So yeah, I don't think, for the sake of simplicity, I don't think that we'll ever see that in the collection framework from the JDK. Now, if this is something that you want to use, you can also use Eclipse collections, definitely. Yeah, other questions?
Doing lately is that instead of using immutable list or immutable set, I just use strings.
Yeah.
Because they're immutable, but only used once.
So the question is about, instead of using lists, you can use streams. Well, a stream is a stream and a list is a list, right? A list really carries data, where a stream does not carry any data. You don't have any data in a stream. A stream is really something that will help you design link pipeline of in-memory processing of data, and you connect that to a source of data. Okay, so it does not carry data. So I don't think that you can replace a stream and a list, because it's really not the same thing.
I know it's not the same thing, but it is similar as the immutable collection. You can, the client that is parsing the stream knows that it cannot be modified.
I don't think replacing one with another will work very well. I'm not sure of that. Okay, it depends on the use case. Maybe on your use case you can do it. Well, if it's the case, well, please, by all means, do it. That's fine. It's not. I mean, you're not going to be fined for that. But it's really. I mean, if the Stream API has been designed separately from the collections framework, it's because there is a reason why the Stream API process data in a lazy way. It does not hold any data. You don't have data within a stream. A stream is basically an empty object, okay, that does not carry no data, and that's why it has been made a separate API, because the concepts are very different. Any other questions about this stuff? By the way, I just talked to you about the list.off. You have the same kind of thing. For all the guys working on Java 8, you also have map.off. Okay, for instance, oh yeah, I don't want to see that. Yeah, and you see that I'm not using the real type for that. I'm using the var keywords. I've been using the var keyword in all this source file. See, this var keyword is also something that you can use now. I think starting with Java SE 9. So if you are in Java 8, you don't have it. and the compiler will guess the type of this variable for you. All right, so this will be an array list of string. Okay, this is a list of string, etc. This label, this gray label, is added by the IDE to tell you what type it is. It's very handy, in fact. It's really very handy. You can use it for local variables. In some cases, for parameters, you cannot use it for fields. Okay, so that's a map of integer and string. If I want to add another key-value pair, I can do that also. You cannot have null values or null keys in it. Don't put null keys in your map. Don't do that, please. Don't put null values in your map. Doesn't make any sense to have that, even if people are doing it. Even if HashMap supports it. It's not because you can do it that you should be doing it, okay? And you can see that here, if I'm using list.of here, I can do that with a var_arg. So I can add as many elements in this list.of method call as I need. For the map.of, it's different because I have the key type, then the value type, then the key type, then the value type. You can see that I've been using two different versions of the map.of. That's the first .of method, and that's the second .of method that is different from the first one. And I can go all the way to 10 key-value pairs. So I have 10 of methods in the map interface. Can I see it? Okay, apparently this stuff, yeah, I need to, let's see. This is key v, and it goes all the way up to 10. All right? So if you have more than 10 key-value pairs, you have map.entries, of entries, okay, and map.entry, one, for instance, okay, and that's another map. We call it map2, all right, map of entries, and this has a var_arg. So if you have more than 10 key value pairs to put, you need to use this of entries factory method with this map.entry factory method to create an entry. By the way, we have a way to create map entries in a simple ways, starting with Java SE9. Have you ever tried to create map entries before that? It's a mess. It's a mess. Okay, and that's for the factory method of list. Any more questions? No, it's okay? Great. I have stuff to tell you about streams. Well, that's a stream. Okay, there was a question about streams just a few minutes ago. And it tells me that there is 5 elements in it. Okay, which is expected. I have 5 elements in that stream, so that's great. Now, you all know the peek method of the stream interface, do you? It takes a consumer. It's basically the same method as the for each method. Takes a consumer as an argument, and it will pass the element of the string that has been processed to this consumer, so you can do anything with it. This peek method has been added to debug your streams. You shouldn't use this method in production. Okay? So if you do, well, remove it. Don't do it. What do you think this code is going to print? Just think about it. And I'm going to show you the result. And now you're telling her, oh, there is a bug in Java, because I should be able to see all the elements being processed by the stream, but it's not the case. So what do you do when you see that? Well, you go to Stack Overflow or to Reddit and make a post. Java sucks. Java is buggy. Look at that. This simple code is not working. It's not working. It's not that it's not working. It's working. Because to count the number of elements of that string, you do not need to process them. It's a string built on the list. How do you know how many elements you have on the list? You call the size method. And that's it. And this is what the Stream API is doing, which is an optimization, and which conforms to the specification. What is wrong here is that I'm doing a side effect, and because when I call count, in that precise case, I do not need to pass the element to the consumer because it will not change the result of the stream. Well, the stream API doesn't call this consumer, and it's perfectly fine. Now the problem is that this pick method, you are not allowed to call this pick method on well, you're not allowed. You are allowed to do it, but it's clearly stated in the Java doc. Do not use this pick method for other purposes than the debug purposes. Now, if I create a list, no, not this one, var list equals new arraylist, and this is a mutable arraylist. I'm going to make it a list of string. If I do not add this type here, this is going to be inferred as a list of objects because I didn't tell that it's a list of string. So if you want to have a list of string, you need to tell if you are using the var keyword. And now I'm going to use this map stuff and say, okay, I'm just going to return S to uppercase. Yeah, to uppercase. But because I'm a smart guy, I'm going also to add this to my list. That's a side effect, okay? And you know, because it's written in the doc, don't do any side effect in an intermediate method of the string. What do you think is going to happen here? How many elements do I have in my list? Sorry. This is my list. Well, because the count method does not need to call the function from the map method to compute the result of that stream, this function is never called, and my list is empty. And now I have a bug in my code, because I was doing a side effect in an intermediate method of a stream, which is something I shouldn't be doing. So don't do that. Don't do that. If a stream can compute the final result without calling the predicates or the mappers or whatever within your stream, it will not call them. Note that this map method has been called. What has not been called is the function that you pass as an argument, because it's not needed to compute the final result of the stream. Okay? And the same goes if I call, for instance, limit 3. Sorry. Skip 2, limit 2, skip. Okay? It will be the same. So this example is simple, okay? But on a more complex example, you may come across the same kind of problem, and it will be harder to tell what's really going on. All right. The optimization comes from the fact that all the streams, here I have one stream there, a second one there, third one, a fourth one, and this is working on a fourth stream of my pipeline. All these streams have the same property, which is the sized property. Okay? Internally in the stream API, there are a set of properties that are kept, and here one of these properties is called the sized property. And if this stream is sized, it means that you do not need to process the element to know how many elements you are going to process. And this count method really is doing that. All right. Yeah? Sorry, I can't hear you. If you call filter, then your stream is not sized anymore, and then it will have to call this function stuff. Okay, if I call filter here, okay, even if this filter is completely dumb, then the stream returned by this filter stuff is not sized anymore. So this one is not sized neither. Then it needs to count the element and then to process all the elements of the stream. Okay? So that's and this optimization has been introduced recently. I wouldn't be able to tell you the exact version, but it's between 11 and 17. So you may have streams that are working in 11 and that are going to work differently in 17. So be super careful with that. Don't do any side effects, blah, blah, blah. Yes, question? The peak thing, I think the peak thing was already in 8.
I mean that the peak doesn't, is not called when you count.
The question is about the peak thing being called or not in 9. I wouldn't be able to tell you, really.
It's called in 8, but not in 9.
It is called in 8 and not in 9. The peak method is called. What is not called is the consumer that is in it. Okay? No, just to be... Okay. It depends on the... It depends... It depends on the case. Depends on the case. Yeah, you're right. It depends on the case. Yeah.
Obviously, this is like a real nuance that you need to be aware of. There's no warnings or anything going on here. It's just something you've really got to be aware that's happening. Other languages...
That's why I'm showing that to you. Right?
I need to go and tell the team, yeah. Other languages like Rust, they'll give you these hints up front.
Yeah.
Is there any plans to introduce something like that with Java?
You mean like what?
As in, like, we would, you know, like a compile time warning, something
Ah,
like this.
you would like to have a compile time warning to do that. Well, so far you don't. But you saw the code, and I'm running Java 17. I don't have any warning, right? It could come from the IDE, I guess. Would the compiler be able to see that? Well, the compiler needs to be able to see that you're on a string that is sized. Yeah. Okay? So what the compiler could tell you is try to detect a side effect within a function or a predicate. This side effect could be done. I put the side effect in a consumer or in a function, but it could have been put in a predicate. Yeah. Okay? So could a compiler be able to detect that a side effect is done within any kind of lambda expression that you could pass to a method of a stream? That's what would have to be done to produce a warning.
Yeah. Because it's like because you've done the optimization.
Absolutely.
So you know that you've had to remove stuff.
Yeah. The question is now then that there's optimization is here, how could we get a warning within the IDE about we are doing a side effect here that is possibly not going to work in a start with this optimization? Right now it's not done. So you need to be careful. You need to check your streams. I would say just don't do any side effects in your stream and that's it. Okay, it's really not a good idea to do that. Creating a list from just as I just showed you here, this is really very, very wrong code. Don't try this kind of code. And this is the kind of code I saw in real applications many times. So yeah, just remove it. Just be the boss and tell you beginners don't do that. It's wrong. All right, I got 8 minutes left before the coffee break, because the coffee break is at 10:30 sharp, and I don't want anyone to miss this coffee break. So I'm just going to start the next demo and interrupt it if it's the time to interrupt it. I'm going to comment this out because I don't need it, and I'm going to start from here, right? So this is the text block. Now you can recognize it, okay? And I'm going to stream it, with the lines method. Now I have a stream of lines from within this text block, and I'm going to map everything with this integer parse int method, and I'm going to just print this result. What I could do is call this toList method. Okay, I have a toList method on a stream API now, and I'm going to put this in a list. Var toList equal this. It's a list of integer, as you can see, and I'm going to print it. Okay, and if I run this code, well, I have 1, 2, 3. Those are strings of characters. Those are not integers. No, sorry, those are integers precisely, not string of characters, and it's working fine. Now, this toList method is a method that has been added recently on the Stream API. You could say, oh, this is a shortcut for the well-known collect collectors.toList. And in a certain sense, this is the case, but it's more efficient than the collectors.toList, right? Why is it more efficient? Because collectors.toList basically creates an array list and will begin to fill this array list with the elements that are coming from your stream. And if this array list is too small, at some point it will copy the internal array of this array list in a bigger array with system.arrayCopy and give the previous array to the garbage collector. This is how ArrayList is working. Now, this toList method will use the fact that this stream may be sized. And if it's the case, and we just saw what is a sized stream, okay? And if it's the case, it will create an array of the right size to fit it, thus saving you from having to copy the internal array from a smaller one to a bigger one if you need it. All right? So you will save on this overhead, thus making your code faster. In some cases, not in all cases. Now, the other thing is that this list is immutable. Okay? If I try to add 10 to it, I got an unsupported operation exception. So in the case where you do not need to mutate this list, you can replace your collectors to list with this guy. It will be faster when it can be faster, and that not in all the cases, okay? But it's immutable, so you need to be aware of that. And you saw that we also have a different behavior towards the fact that you can put null values in your lists, in your previous example. Can I put null values in this list? I'm going to map it. I'm going to do something completely crazy. Okay, to null. This is crazy. Never do that. Unless you've just been fired and this is your last move on your application. No, even. No, never do that. Never. That was a joke. Okay, so it supports null values. So as long as you do not need a mutable version of your collect.collectors to list, you can safely replace collectors to list with to list, even if your stream is processing null values. Okay, that's the idea behind that. That's the idea behind that. All right, I'm going to remove that. It was just to show you. But so this is very very handy. Okay. And now, suppose that someone has something to do. I have something to add. What is going to happen if I run this code? Oh no, an exception. Number format exception. How can I get rid of this number format exception? It seems like I need to add some kind of filtering. Okay? Filter. Take this string. And how can tell if I can parse it or not? Well, I probably need to parse it. Integer.parse int of s. And if I can parse it, then it's okay. I'm going to return true. And if I can't parse it, then I'll have an exception, and I'll return false. That's filter. Yeah. What do you think of this code? Who thinks it's good code? No one. Well, I agree with you, but at least it's working. Why is it not good code? It's working. Hey, it's working, guys. Well, probably the problem is that to know if I can conduct the mapping, I have to conduct the mapping and see if it works. So I'm basically doing the mapping twice, once here and once here. But how could I avoid that? Well, what about, that's a cliffhanger. That's an excellent cliffhanger. What about we have a coffee break now, because it's 10:30 sharp. And if you want to know that, you will just need to attend the 5 first minutes of the next part of this session. Okay, we do that? How much time do we have? Is 15 minutes okay? Yeah, 15 minutes okay? So that's 30 on my phone, let's say 45. We take it from here at 45. Thank you. Okay, was the coffee good? I hope so. I hope so. Okay, that's the slide I'm going to show you in a few. All right, so we had discussions about this problem, and in fact, when you need to tackle this kind of problem, you need to have clear ideas about how the Stream API has been designed. Okay, there are 3 main intermediate methods, important methods that you really need to understand in a Stream API. The first one is the map, the second is the filter, and the third one is the flat map. And the important thing, from my point of view, with the map method is that if you have 50 elements to process, this map method is going to process those 50 elements and will return you a stream that is going to process 50 elements. The map method does not change the number of elements you have in a stream. This is why when you map a sized stream, you get a sized stream at the end of it. Now, the filter only removes elements from a stream. If you have 50 elements in the upstream, you will have 50 or less elements in the downstream. And with the flat map, you can do both. You can increase the number of elements, and you can decrease it. So the flat map can act as a filter. That's the gist. And precisely this is what we're going to use there. Okay? Instead of doing that, which works, but which doesn't make any sense, we are going to take just this code. I'm going to remove this. We are going to call flat map, paste this code, and you know that the flat map takes a function that should be producing a stream. So I'm just going to return a stream with the result. Sorry, I got this guy. I need to get rid of this guy. And if it doesn't work, if I have an exception because this integer that passes in through this exception, what I can do is return an empty stream. Now, this function always returns a stream. This stream is empty if I cannot process the conversion, if I cannot convert this string of characters. Okay? And if I can, then it returns a stream with only one element in it. And if I run this code, now it's working properly. You see that this flat map helped me to kind of fuse both the filtering and the mapping in one operation. So I solved my problem. Did I solve it in the right way? Well, if I'm in Java 8, I don't have any other solution, in fact, so I would say yes. But it's not that great, because I am creating this stream, this intermediate stream in that method, and there is an overhead in doing that, even if it's not that big. And this overhead is kind of useless, because it's just here to do the filtering stuff. Okay? But up to Java, I think 16, I can't remember the exact version of the right solution I'm going to show you. This is the only solution I have. Okay? So I'm going to get rid of this one. And instead of calling flat map, I'm going to call this new method called map multi. Map multi, gosh. Okay, that's enough. I tried to scroll down to find the button I need to click to get the proper Java doc, but it didn't work. Okay, this map multi takes a big consumer with 2 elements, an element of a stream, of the stream I'm processing, and another element that I'm going to call stream. Now, this stream is not a stream, it's a consumer that models the rest of the stream. Okay, and if I want to do something with it, if I call stream.accept s, this s element will be sent to the downstream, to the stream returned by this map multi stuff. all right? So it does the same kind of thing as the flat map without the overhead of creating a new stream. If I call this twice, then I will add this element twice. And if I do not call it, I mean, if I just do this, okay, this is going to work, and the downstream will be empty because I never called the except method. All right? So now you can see that I can easily take this code, and instead of calling return stream of blah, 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 I'm just going to call stream.accept and pass this in that way. And if I'm here, I'm just going to do nothing. Okay? I don't return anything. This method does not return anything, right? Just called accept with what I want to transmit to the downstream. And if I run this code again, as long as it compiles, it should run and produce the right result. All right? So this map multi method is a kind of flat map. It works the same as the flat map with a different pattern of code, but without having to create those intermediate stream, thus saving on the creation of this stream, which is nice, which is exactly what I want. Now, there is still something that you need to be aware of. Can I? No, I can't. You see that here, he lost the correct type of the var I have here. This var is now a list of objects. You can see it now. And if I want to make it a list of integer, the compiler will not be happy. I will have a very nice exception. Yes, it's nice. Sometimes this kind of exception is really ugly. Well, the error message is really ugly, but currently it's kind of okay. Because what he sees is the list of objects. The reason is that the type of this stream here is a stream of object if I do not give the proper type. But I can also tell, okay, this is a stream of integer, so I can give the correct type of the stream here. Because this map multi method, we're probably going to see that there is an R type there that is the type of the consumer. Okay, this consumer is the model for the downstream. This is the object on which I call the accept method. They called it a mapper in this source code, which is very confusing. It's really a consumer. It's really a consumer. Okay, don't look at that. Well, my advice: don't look at that. It's really not easy to understand. Just understand how to use it. And that is the type of the object of the downstream that is going to be produced by this map multi. All right. By the way, this example is in the dev.java website that I just showed you at the beginning of this presentation. So if you feel like going to the dev.java website to check for the documentation of the map multi, you have this example in it. I know it because I put it there. So. Okay. So that's it for the stream. I'm going to bypass the switch expression because we're going to talk about it a little more. And we're going to talk about records. Okay? Who heard about records in Java 17? Almost everyone. That's great. I would like to show you something, which is this slide, which is which is the evil plan to dominate the world of the Amber project. And you can see that the Amber project started in Java 11 to bring pattern matching to the Java language. Records have been added in 16, along with pattern matching for instanceof that we are going to see. Okay, and in 17 we have a pattern matching for switch as a preview feature, and I'm going to show you what it is and how you can use it. You won't be able to use it right in 17 because it's still a preview feature. So it may change in 18. We'll have a second preview feature probably in 18. And if we're lucky, we may have it as a final feature in 19. But 19 is in less than a year because we are on a 6 months release cadence. Okay? And in 18, we should have, it's not sure yet, but it's there is a preview JEP that is almost on stage, that is called record on array pattern matching, which is another step of pattern matching. Okay. That's the slide. Okay, let's go back to the IDE. So what are records? Records are classes, and you can use them as regular classes. Here is a record you see on line 7. I called it range. All right. It's a class. It's compiled as a class, just like an enumeration is compiled as a class. You know enums from Java 5, 2004. Well, records are just like that. A record already extends internally a class called record, so you cannot extend anything with it. You see, if I want to extend, I don't know, even objects, by the way. Okay, I will have a compiler error, so we cannot do that. And it's compiled as a final class, so you cannot extend a record because it's final, just like an enum. You can't do that. All right. A second restriction on record is that you cannot add an internal state to it. Okay, even if I make it private, even if I make it final, I'm not allowed to do that. To define the state of this class, you need to define this, which are called the components of this record. This component it's really a new notion within the language. It's related to records, all right? If you check the reflection API, you will see that, yes, you can get the component. You can check if a class is a record, and you can, if it's the case, you can get the components of this record. You have a get component method in the reflection API. So it's really a thing. And if you check the annotations, for instance, you know that on the annotation, you have this enumeration. If you define your own annotation, you will tell, I want to be able to put this annotation on a type, on a field, on a method, of an argument, many things. Well, you can put them on components too, directly. Okay? What are those components? Those components are going to be mapped to private final fields within the class of a record, as expected. Okay? It's going to be used to create a special constructor in the record that I'm calling here. Okay, I didn't write any constructor to this record, but I can still call this constructor because the compiler added it for me. Okay, and the compiler also added accessors. I have a begin method and an end method that are going to return begin and end. And also I have, if I run this code, you will see that, yeah, I also have a toString method, and also an equals method and an hashcode method. So constructors, accessor, toString, equal, hashcode are all created by the compiler for me. I do not need to add that. Okay? Great. If you want to override that, you can, well, override. If you want to redefine them, you can do that. And it's especially useful if you need to do some kind of defensive copy of a list that you could beget as an argument. If you want to defensive copy this list, you can do that by redefining the constructor. Now, there are restrictions to it. Okay? For instance, if I want to create an empty constructor, range, sorry, I can do that as long as this empty constructor calls the constructor that takes the two components. So for instance, this is legal. But if you want to define your own constructors with overloads, if you want to define your own overloaded constructors, you can do it as long as in the end you call what is called the canonical constructor. Because this canonical constructor, that I'm going to write explicitly, this dot begin equal begin, and this dot end equals end, this canonical constructor has to be called when a record is constructed, all the time. Okay? It's mandatory. You cannot create this record without calling this canonical constructor. It's carved in marble. If that means something to you. All right. So now this is very interesting because if I want to add, for instance, a validation rule, if begin greater than end, then I don't want to create this range object. Throw new illegal argument exception. Begin should be greater, end should be greater than begin. Okay, so if you want to add, let me get rid of this. So if you want to add your validation rule, you can put them in the canonical constructor. They cannot be bypassed. They cannot be bypassed. Now, probably you already saw that, but even my ID is telling me, oh, but you know that you can simplify the constructor. And I can convert this canonical constructor to the compact constructor, which is this one. In fact, I do not need the compact form of the canonical constructor, does not need the arguments, because the compiler knows what the arguments are, all right? And it does not need to copy the values of the argument to the internal state, because the compiler can do that for me. So you see that writing a record is really a matter of defining the components, defining the validation rules of these components, and that's it. There's no more to it, which is really great. You can implement interfaces within this. Let me implement interable of integer, for instance. So I'm going to add this iterator method. Returns a new iterator. No, it's not iterator, it's iterator of integer. I can create an internal state. Private index, no, that's in it. Index equals begin, I'm going from begin. Okay, I got a next element as long as index is lesser than end. And what I want to return when I'm calling next is index plus plus. And that's it. And now I can iterate over this range because it's an iterable. It index in range. And let me call that, run this code. And this is going to print this, which is expected. Okay? So records are really super simple pieces of state that you can add. It carries a state that is supposed to be immutable. So if you pass a list or an array or this kind of thing, or date, as a legacy date, you should definitely defensive copy it in a canonical constructor and in your accessors also, if you're using mutable versions of to model the internal state. And you can add any kind of implementation you need if you need them, which is awesome. Let us put it in that way. Great. Now, I told you that there was no way you could go around the validation rules of your records if you add some to the canonical constructor. It's even the case for serialization. And this is really new, and this is super interesting, I must say. Okay? Here I have this range record, which is basically the same as the one we just constructed. I have commented out the validation rule, and here is the same thing with a regular class, right? A class from Java 8, for instance, or Java 7. And there is also a validation rule in it, but I'm going to get rid of this. But, oh, I can keep it. But I just commented this class out, all right? And this code is going to create a range with the class. It's an illegal range because the validation rule has not been added yet. And I'm just writing this range serialized in this file, okay? So let me run this code. It's done. Doesn't take too long to do that. And now I can reread this range. This is the rest of the code. I'm reading it directly from the class, but I had a bug report, okay? People told me, oh, you have corrupted ranges in your application. You need to add this validation rule. And I've added this validation rule in the constructor. So now I have a valid class, non-corrupted, with only one constructor. And in this constructor, I have a validation rule. So I expect all the instances of this class to be valid against this validation rule. But now the problem is that I have this old version of this class, in a file which has been created before the validation rule was set up. All right? So what happens if I deserialize this object? Well, the problem precisely is that nothing happens. This object has been deserialized in this class, and I do not have this message here because this constructor, which is the only constructor in this class, has not been called. Well, because the serialization process completely bypasses everything. It doesn't call any constructor. It doesn't call any accessor. So it bypasses all the validation rules that you can set up in your application, which is some kind of security flaw. Could we agree on that? Okay. If this code is malicious code, this serialized stuff is malicious code, then it can really create a mess in my application. What I would like to show you is how things are working with records. Okay, so now I am going to use the range record, which is just this guy. Okay, so I'm going to create a range record that is corrupted, but it's not really corrupted because the validation rule is not there yet. All right, so I'm going to run this code, create this range record which contains a serialized version of this record that is not valid. Okay, now I have my Jira ticket. Hey, you forgot the validation rule. Oh my God, what did I do? Yeah, okay, and it's here. Great. And now what is going to happen if I try to deserialize this record? Okay, now I have this invalid record in my deserialized stuff, and I'm going to recreate. But what I told you is that the canonical constructor is always called. So I expect to have an exception. And indeed, I have this exception that has been launched with the correct message and must be greater than begin. All right, so the point is that deserializing a record is calling this canonical constructor, thus not bypassing your validation rule, which is new. So it makes record a very good choice for all your data transport objects, all your DTOs, especially if you serialize them to pass them from one part of your application to another. Probably using Unix domain socket, for instance, the stuff that I showed you at the beginning of this presentation. Now, how can you refactor your code? Because if you need to refactor all your DTOs to be records, this may be a very hard work to be done. What I'm going to show you is just 2 lines of code to put somewhere on one place and 2 more lines on another place to leverage this stuff without breaking all your, not breaking, but without having to refactor all your application. And this is sorry, I'm not showing you the right code. What I'm going to show you, this is your range legacy class. Okay, it's a plain class that is serializable. I just added this validator in its own class to externalize it, kind of. And I have this constructor that is not going to be called by the deserialization process. And this is wrong. What you can do is say, instead of writing this class, I'm using a mechanism that have been added in serializations in the very early days of serialization, 25 years ago, which is the write, replace, read, resolve mechanism. Okay, so I'm just using a very old mechanism of serialization, which in fact serializes a proxy object instead of the current object. And for that, you need to add this method here in your legacy object, in your legacy class, write, replace. It has to be object, write, replace, throw, blah, blah, blah. So a little complex. So you have this new annotation telling the compiler, hey, this is some serializing stuff, so please help me check that if I make a mistake, I will have a warning, oh, this is not part of the serialization mechanism. All right? And what this method, the role of this method is the following. It's called by the serialization process to serialize this object instead of the range legacy object. Okay? So the idea is just to add this in your current DTO, and you can see that's a system out println, so it's really 2 lines of code, including the method declaration. This record, which is the record that is going to carry the state you want to serialize, and now this is the record, so this is new code. And in this record, to recreate your legacy object, you need to add this read-resolve method in it. Okay? That is going to map the state of this record to your legacy DTO. Okay? And now, in your serialized information, in your serialized file or stream or whatever, you have a record that is going to be recreated with its canonical constructor. So you are leveraging in your legacy code this new mechanism. Okay? And I'm going to show you how it's working. It's really simple. I think it's this code. So now I am creating a range legacy that is not valid against my validation rule. I'm going to put that in this file. All right, so let me run this code. Yeah. Sorry. I need to comment the legacy, the validation rule. Where is this? Yeah, okay. Let me run this code again. So now I have a range legacy that is not valid. Okay. I am going to go in my range legacy, add this validation and to my range proxy object and add this validation rule. So now I have fixed my bug and I say, okay, my objects need to be valid against my validation rules. And if I try to deserialize my legacy object, let me go back to this guy. So I'm going to comment this code and uncomment the deserialization stuff. Let me hide you. Okay, so this is the same file I am deserializing. Okay, because what I have in that file is really a record, the validation rule has been enforced, and I cannot create this invalid legacy object anymore. Okay? So if you want to leverage this, if you are using Java 17 and want to leverage this validation process in your serialization mechanism, you can do that quite easily. Just create a record, add this write replace read resolve method, write replace in your legacy object, read resolve in your record, and it will do the trick. So it's quite simple to set up. Questions? No? It's okay? Great. It's not the only thing you can do with records. And I'd like to show you how you can use records to make your code more readable. Okay? So this is, we've been talking about streams, so we're going to play with streams a little more. I have a file here. It's a basic CSV file with cities in it. It's just something I copy-pasted from Wikipedia. The link is here. So for each line, I have a city along with its population and land area. Okay? And those are cities from the United States. And so I created a record with the name, the state, the population, the surface, and I just added a factory method to read the line and create this city record. Okay? And now I am reading this file. I'm creating a list of cities, which are records. So I would just like to go through all these 3 examples to read all the states of the cities. So I can just stream that, map to the state, maybe called distinct. Okay. Put the result in a list. So this is a var list. Well, let me call it states, just like that. Okay, I'm not going to print all the result, but what I can do is just get the size of this stuff. Okay, yes, I've run the previous code. This is not what I want to do. Okay, so I have a little more than 300 cities and a little less than 50 states. Great. And now what I want to do is get the population for each state. and that's a job for the grouping by collector. It's basically regrouping all the cities by their states and summing the populations. So I can do this kind of thing. Cities, the streams. I can directly collect that. Collectors dot grouping by cities, and what I want to group by is cities. Sorry, city the state, and I can downstream the stuff, summing the city, not dot ID, dot population. Okay, I can put the result in a var, and this is a conversation we had, a quick chat we had during the break. If I say, okay, this is a var map, then thanks to this idea, I know what the real type of this map is, but sometimes putting the real type makes your code more readable than putting var. And I think that should really be the rule. Using var is great, makes your code shorter, probably more readable, but if I think that the real point is improving the readability of your code. So if you think that var makes your code more obscure or whatever, you don't have to use var. It's not mandatory. You can use the classical way of doing it. But what you can do also is use static imports, right? Sometimes static imports are really great. And here there is no ambiguity. I'm using the collectors factory method. Okay, I have a map of string of integer. And if I pass this map to some kind of external method whatsoever, it's just a map of string of integer. What is the string? Is it the city name? Is it the state name? Is it some other stuff? It's not super easy to do that. How could we improve that? What is it really? It's a map of state of integer. Okay? Well, it's not that easy. It's very easy with record to create new types, right? Because a record is just a wrapper on a type. So I could say, oh, this city is just, instead of saying that this is a name, this is a state. Okay? It means that this is not a string anymore. This is really a state. Why aren't you working? Oh, because I messed up with this. Yeah, that's better. Okay, now a city has a state, meaning that, where am I? Yeah, city.state, you see that now this var state is not a list of string anymore, it's a list of state, really, okay? And now my map magically became a map of state and integer instead of a map of string of integer. I just improved. You see, if you've read all the books about clean code and things like that, people say, give proper names to your variables so that the business meaning of your variable is clear. But what you can do also is use the type. All right. I guess that the clean code says that because creating types is maybe a little expensive. But with record, creating a new type is really not expensive. It's really super easy and super light. So if you do that, you will just improve the readability of your code. And now if I try to, how can I call this map? Population by state. By the way, I could do the same with this integer. It's saying that this integer is really a population. Okay. Now, if I want to know what the most populated state is, the trick is to do the entry set.stream and get the max. And I have this very useful map entry .comparing by value factory method on the map entry interface directly. And this is going to bring me an optional. And you know that now you shouldn't be using the get method of optional anymore. Instead of using the get method of optional, you should use this one, or else it does exactly the same, but reminds you that an empty optional will throw a nasty exception if you're calling the get method on it. Okay. And this will return a map entry of state and integer, which is the most populated state. Not too bad. And I can print the result and see what it gives. So it's working. Okay. Now, what I have here, oh yeah, I can't show it to you. Yeah? What I have here is very generic processing of a map. And I have the exact same problem than the previous problem. What does it do really? Just take the map, consider the values, and get the max by value. Okay? But the value is a population. And this map is really an aggregation of a state and its population. How could I put it in my code? How could I write that in my code and to give some business meaning to this code? Well, I have records. Okay? Population state, I don't know. Column new. Okay? That's a record. How did I call it? Population state. Okay, it has a state and a population. And I need another constructor on it that is going to take a map entry. Okay, let me do that. Population state is going to take a map entry of state and integer, which is the population. That's the entry. And you remember that all the constructors of a record need to call the canonical constructor. So I'm going to call this entry.getKey, which is the state, and entry.getValue, which is the population. And now what I have here is a stream of population state instead of having a stream of map entry, which is not super readable. Of course, this guy is not working anymore because it's the comparator of map entry. But what I could do is say, okay, I'm going to call this comparing by population. I could follow the same pattern as the one I have on map entry and say I'm going to create a factory method on this population state record to create a comparator here. And I can leverage the comparator API to do that, saying that I'm going to compare by population state, column, population. And this is not a map entry of state and integer. I'm going to call it var because that's convenient. All right. You see that, it's not such a big deal. I just created two very simple records and just do very small refactoring on the stream stuff. But, I think that the result is much more readable. Now I understand what I'm doing. I understand what this stream pipeline is doing really. Okay, so this is something that record can bring you to make your code more readable. Okay, that's for the record. Yeah, question?
Yeah, for those of us who are using non-block annotations to add value to
Ah.
that data, what extra does record actually give us, apart from like the security fix of like serialization?
Apart from the security fix about serialization. The question is about Lombok, right? Is there a question about Kotlin and data objects? Because I could take the two questions at the same time. If you have Lombok and you like Lombok and you're used to it and all your team is used to using it and you can't move to Java 17, by all means, continue using it. What you need to understand is that a record is not compiled in the same way as a Lombok data object or as a Kotlin data object. If you check the compiled code, check the bytecode, you will see that, in fact, a Lombok data object is just a plain Java bean that is final with a final state, and with the toString equals and hashcode methods that are just the compiled version of what your IDE could have generated for you. Okay, that's the idea. And the same goes for Kotlin, by the way. If you check the bytecode, this is really what's in it. If you check the bytecode of a record, you will see that the toString equals an hashcode method have been compiled using invoke dynamic, meaning that the code is in the JVM. So if you create records in your Java 17 application, move to Java 21 in 2 years, you will change the JVM. Without recompiling your code, you will benefit from the optimization you may have on the implementation of these methods, thus improving your performances. If you want to do the same with Lombok, I'm not going to talk about Kotlin because I'm not Kotlin expert whatsoever, but if you check the thing with Lombok, if you want to leverage optimization with Java 21 that may appear in Lombok between now and the 2 years to come, you will have to recompile your code. This has a cost. So you may be answering me, oh yes, but we recompile our code all the time anyway, so okay, that's fine. But this is what you need to have in mind. And this serialization stuff is really something that, oh my God. It's a security fix, right? Just use it. Just use record just for that. It does not mean because you're using record for that, you can't use Lombok for your other objects. You can do both. But by all means, fix your serialization problems. Any other questions? Yeah, please. Oh, you need to shout. I can't hear you. Sorry, you shout louder.
Okay, so I thought that when I would start using records, I would be able to drop Lombok. It was mentioned here, right?
You can drop Lombok.
Yeah, but one thing which prevents me from is this convenience of using the builders from Lombok, right? So is there any plan
To use the what from Lombok? Sorry.
the builder method?
Oh, the builder methods.
So when you have large number of arguments in your constructors, sometimes, and then some of those like new or like they are optional, then you really like to use those builders. So the question is there any plan in the future releases of Java that maybe those builders or some version of it should be added?
There is. I don't heard about any plans to have any kind of builder, automatically generated builder pattern to create records. Now, if you have records or object with too many fields, then this is your problem. Okay, this is a problem in itself that has been well known for years, at least since clean code has been written. Okay, so you need to address this. My point of view is you need to address this kind of problem. Maybe you can, I don't know, split your fields into several parts and have nested records, this kind of thing. A record can be a field for another record, right? But if you have an object with 15 fields, then you have a problem, whatever solution you're using. That's my point of view. Yeah? I'm the one with the mic. Is it possible to write map records?
Yeah, to other objects. If you want like to transform it into like few objects using map like constructors.
You mean you would like to use a record as a proxy to another object? Is that? Yes, you can write the code to do that. Absolutely. A record is just a regular class. So anything you can do with a regular class, you can do it with a record. It's just the fact that it's a record is just a syntactic stuff, right? But the compiler sees that as a class, and compiles that as a class, by the way. So anything you can do with a regular class, by all means, do it with a record. Yeah. 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 Yeah.
Where it kind of seems like you could use type inference.
Where can you do? You mean using type inference? Where do you want to use type inference? Sorry. You mean here? No, you need to tell the compiler that this is what this is. The compiler cannot guess this type. You mean if I get rid of this? Yes, but this var here is inferred from this, which is a string. What I could put is new state here. And now the state is, this object is now a state. That would work. But as long, the type of this variable is inferred from this line, not from this one. Is this what was your question?
It was more or less, yeah.
Okay. Yeah. So you can do both. You can do both. Really. All right. So that was for the record. Great. Do you like it? I love it. Really. I love it. I would like to. Yeah. No, we're going to move. At some point, there is a word of warning I need to show you. Okay, we'll do that later. Never mind. All right, so we did that. I would like to talk to you about seal types. And you're going to tell me how records are related to seal types. Well, they are related to seal types probably with pattern matching, but not yet. What is a seal type? Seal type it's not a preview feature. Now we are arriving really in Java 17 because it's a final feature that has been added to Java 17, so just 6 weeks ago. What is a seal type? First, a seal type applies to classes, abstract classes, and interfaces. I'm going to show it to you on interfaces, but you can really use it on any kind of types. Okay. So I have an interface that is called shape. And it's a very, very original example, okay? And I have a record that is called square, and guess what? This square is going to implement shape. Wow, that's brilliant. Okay, so I'm going to make it a sealed interface. Okay, sealed interface. And while I'm doing that, I need to tell the compiler what types are allowed to implement that interface. Okay. So I'm going to take permits, square, and rectangle. Okay? It does not compile because square needs, of course, to implement the shape. There's no magic behind that. Still need to implement the shape. And the same for rectangle. Let me put it here. Okay? And now the compiler is happy, and my code is compiling properly. A seal type must declare the types that are allowed to extend it. That's the gist. All right? All these types need to be either in the same package if I'm not using modules from Java EC9, either in the same module. Why? Because the compiler wants to see all your hierarchy when it's compiling it in one pass. So you can't say, oh, I have this interface that is sealed, but you will see this square class later in my compilation. No, it doesn't work like that. Okay, everything needs to be in the same compilation unit. Can be in the same file, by the way. All right? There is more. The classes that are implementing this interface needs to be either final, and this is the case for this record because, as I told you, this record is a final class. It's compiled as a final class. Either a regular class. I'm going to permit this random shape. Please implement this shape for me. But now it's not compiling because it's a regular class. And I need to say that this class is either final, and this is going to fix my compiler error. Either it is sealed itself, and I will need to add a permit clause with the same kind of thing. Either it can be, or it can be non-sealed. Non-sealed means that you can extend it freely. Okay? So this seal type stuff is a mechanism by which you can decide either to have a completely closed hierarchy of types with interface classes, abstract classes, or allow extension on certain points. You see, but all the status of the classes that are implementing the shape interface needs to define, hey, I am final, or it's okay to extend me in that way, either freely with non-sealed, either using this sealed mechanism. Right? So what can I do with that? I'm going to remove that because I don't want this random shape. I'm not happy with random shape. So I'm going to remove it. What can I do with that? Well, suppose I want to create a surface method that is going to compute the surface of a shape. If I am pre-Java 17, without this mechanism I'm going to show you, what should I be doing? Well, I'm going to take this method and add int surface on my interface. And the nice thing with that is that in all the classes that are implementing this interface, I have a compiler error telling me, hey, you should be really implementing this method. And you didn't. All right, this is the nice thing. But what is the cost? So on the one hand, I have this nifty mechanism that tells me if I forgot to add, to implement this method somewhere, which is nice. But what is the cost of that? Well, we all know the cost of that. The cost of that is every time you need to add some behavior to your model class, you add a method somewhere. And you end up in a situation that, of course, nobody never met. Never came across that. With business objects with 50 fields and 70 methods. That's the price. That's the price to pay. Okay? Well, you could say, well, it's not too bad. Okay, we have big object. This contract object it's huge object, 2,000 lines of code, 43 fields, 76 methods. All right. It's not too bad because, okay, what's the price of having that? Well, if I'm working on a business module, particular business module of this application, and I have to use this contract object, every time there is a modification on this contract object, I have to take this modification, all right? I have to update my code. I probably have to recompile it, even if the modifications are not used in my module. And that defines what a monolith is, okay? I'm not working on a module, in fact. I'm working on an artifact that is on its own project whatsoever, code base whatsoever, but I'm depending at compile time of these classes, even if the modifications of these classes are not used in my code. That's the first cost. The second cost is every time I need to write a test, I need to instantiate this contract object. Okay? And if I have validation rules in it, these validation rules have to be enforced. So I cannot write it completely freely. I'm not defining this object, other people's are. And I need to follow their rules. And I end up in my coding test to have super complex factory methods just to create objects. And probably in this object, I only need 2 fields and 3 methods instead of the old state. That's the cost of having this kind of thing. Okay? So instead of doing this, I could say, all right, I'm going to add this, I'm going to add this surface method outside of it and get a shape as an argument. All right? And now what I'm going to do, what can I do here? Well, I still have several implementations of this shape interface. So I need to check that. If shape is an instance of, what was it, square? No, not savearg. Of square, I need to do something. And if it's an instance of rectangle, well, I'm going to do something else. What I'm going to do? Well, it's just computation of the surface. So I guess we all remember the formula. We need, you know what? I love this IDE. See? Tells me, hey, you can use the edge method that is on the square object that you just checked. Right? It doesn't show me the get width or get height. I just have the cast that is made automatically. This is so great. Okay, So that's the surface of the square, and I'm going to compute the surface of the rectangle real quick. Shape dot 8 times shape dot width. Okay, and this is going to work. But what is going to happen? The gain here is that my shape objects are kept simple, and I'm only pulling the behavior I need from these objects in my business code. But if I add a circle there, okay, and say that this circle implements, shape. When I'm, gosh, where am I? I'm here, sorry. No, I'm here. Okay? What I lost is that I do not have any warning telling me, hey, you forgot the circle. And if someone had the circle to the seed hierarchy, hey, please, you can go in and take a seed if you wish. You can go in and take a seed if you wish. Okay? I mean, I don't have any warning for this circle, right? And this is something I lost. When I had a class that was not implementing the proper methods, I had a compiler error, and now I lost this compiler error. And now I have a bug in my code, which is not great. Well, we are going to fix this bug. Okay? But before that, I would just like to show you something, because this is really ugly code, isn't it? Who likes this code? Yeah, one person. Oh, thank you. Okay. Would you prefer this one? But I'm going to declare this square here and use this square variable there. Okay, and the same for rectangle. Do you like this one better? Yes, thank you. Okay? Now you may be thinking this is just a syntactic sugar, just a nice thing. I check for instanceof and create a variable at the same time. It's more than that. It's pattern matching for instanceof. It's a final feature, so you can use that in Java 17 as a final and regular feature. It's not a preview feature. It's here to stay. All right? And what is this? You see, instanceof is an operator that takes a type on the right hand of the operator. And now it may also take what is called a pattern. This square is a pattern. How could you understand that? In fact, you can understand in that way, asking yourself, is this shape has been declared as, in fact, square variable? Something like that. Okay? The name of the pattern is a type pattern, because here you have a type, a regular type. It's an interface. It could have been a class. All right? And along with it, you have what is called a binding variable. And this binding variable is created if it makes sense, and you can use it wherever it makes sense in your code. Right? That is, if I want to check, okay, I'm only interested in squares. Oops, sorry. Yes, I don't have internet. I know. Okay. Square. Got edge greater than 0, for instance. I can write it. I can write this code. It makes sense to use this square variable in this Boolean operation. If I replace that with the OR operator, for instance, it wouldn't make sense, so I wouldn't be able to use it. All right. Now, this is nice, but it's not working completely. It's not working properly because I do not have this warning that I would like to have with the compiler. All right. But this is a if, else if, else if, else if. By the way, if I want to check for the circle, I could say, hey, are you a circle? And if you are a circle, then I'm going to return circle dot radius times circle dot radius. Let us suppose that pi is equal to 1, and it will work. Okay. Now, what is the structure of this code? If, else if, else if, else if, else if. Well, this is a well-known structure. This is the structure of a switch. Okay? So in that case, I can say, oh, if the case is a rectangle, then I would like to yield this. Oh, sorry, this. Okay? And if in the case of a square, then I would like to yield this. Sorry. By the way, it's not compiling because this is really what I want to return. Okay? And now it's almost compiling properly. I can get rid of this code, and I can get rid of this return. Okay? So this is a new switch. First, it produces a value. You see, I can return this value. I could say, hey, this is the surface, and return the surface. Okay, so it's a switch expression. It's an expression. And you see that the previous switch we had up to Java 11 was a switch that was only accepting certain integer types for the case constants. That is all the integer types apart from long. It does not accept Boolean, but it also accepts a string of characters and enumerated values. And now it also accepts patterns. Now, this is a preview feature in Java 17. It's not final. We may have it in the future as a final feature. It may change. We may have adjustments here and there. Switch expression are a thing. That's a final feature. But the fact that we can use pattern matching in it is not completely, well, it may still change in the future. And by the way, I used this comma here. What I prefer to use is the arrow-like syntax. And get rid of this yield. No, I would prefer put it in that way. Okay? So it's almost like this instanceof, but it's much more readable, much more clear, less error prone, whatever. And I have a compiler error telling me that this switch expression does not cover all possible values. I added the circle type in my sealed hierarchy, and a switch is able to detect it. It's just like when you have an enumeration, in fact. Okay? If you forget an enumeration value, you may have a warning, or in that case, you will have an error. So let me add the case circle. And return circle radius times circle radius. Okay? And now I have fixed my compiler error. So with seal types and pattern matching, I have the best of both worlds. All right, I have pulled out the business methods out of my class, so I can keep my business, my model class, as simple as I can. All right, it still need to have some state, but it's only a state carrier. By the way, it's a record. And if I want to add behavior, and I forgot one type from my seed hierarchy, my switch expression will tell me that I forgot this type. Yeah, question? Yeah. Absolutely. So the question is, if you have a default, I'm going to comment this and add a default case here. Okay, with some silly code. Well, I'm doomed if I do that. Okay, so I'm just losing this compiler error. So probably good advice would be don't do it. You don't need a default case anymore. So I would say don't use it and get the compiler error to make sure that your code is correct. Yeah, other question? Sorry. Is this not in conflict in the open-close principle? Well, that's funny because that's not the first time I have this question. It's not. It's not. The open-close principle tells you that you should be able to enhance the behavior of your application, to add behavior to your application only by extending classes. Okay, that's the core of the open-close principle. But at the same time, people say, don't use extension. When it's extension, it's really inheritance in the object-oriented programming sense, right? But at the same time, people say, okay, you shouldn't be using inheritance, you should be using composition, okay? So you can implement the open-close principle using composition, for instance, with a strategy pattern implemented with enumerations. You can do that in that way. But what are you going to write if you do that? You are going to write exactly this kind of code. All this code will be written as instance methods of your enumeration. And if you want to add behavior to your application, you will add an enumerated value to your enumeration. Okay? Now, instead of adding an enumeration, an enumerated value to your enumeration, now what you're adding is an implementing class of an existing interface. So your client code will not change, but the behavior, you need to add it somewhere. And instead of adding probably in a lambda expression that will be passed to the constructor of your enumeration, you will be adding it here. This code, you need to add it somewhere. And now you add it here. This is not your client. This is not your client code. This is still your model code. Okay, your client code will call surface, but I haven't touched the signature of this surface method. So in that sense, I'm still okay with the open-close principle. Let me put this one back. Yeah?
So now you have what look like lambda expressions. Will you be able to replace those with function references with double colon?
Should you be able to? Could you be able to replace this with method references? Absolutely. What you need to do is to create a class that will carry this rectangle 8 times rectangle width, okay, which will be composed by this class, and you just call the methods on it. It's just a matter of organizing your code. Yes, but you can do that in exactly the same way as you could do it when creating enumerations to implement the strategy pattern. Yeah?
What happens if this code is compiled separately and then the class C class here stands separately and is compiled?
So the question is, what happened to this code if, for instance, someone adds a class in a CL hierarchy in the object model object module, for instance? Is that true? Yeah. Oh, this node is not recompiled. You will have an error at runtime, because the CL class, you cannot bypass the CL class. Okay. It enforces at compile time and also at runtime. You cannot create another class that is going to implement my shape, my shape sealed interface at runtime using some kind of reflection or agent or whatsoever. Yeah. It will be detected at runtime. I think it's when the class is loaded. It will be detected, and your application will not be able to run. I'm not absolutely sure of that. I would say yes, but I'm not absolutely sure of that. And by the way, this is still a preview feature. So whatever is the behavior right now may change in the final version of it. Yeah? Mm-hmm. Mm-hmm.
And only compile shape and this hierarchy with classes.
Yeah. This code will not work. This code will not run because it will detect at runtime that the CL hierarchy has been changed and that you will be in the same configuration as this configuration this code does not compile. So. And the fact that you're not covering all the elements and you do not have a default clause a default case, will be detected at runtime and your code will not run. Is it that when the class is loaded or when this exact method is executed? I wouldn't be able to answer that question. I need to check that. But it will definitely not work, that's for sure. All right, so that's a mixture of switch expressions and pattern matching for switch, which is, I think, great stuff. By the way, I have two more stuff to say. Sorry, no return. I can handle null values in switch with switch expressions and pattern matching. Okay, so if you want to get trained, currently if you're calling a switch on a null value, you get a null pointer exception, which is not that great. Okay, so you need to check for the nullity of the argument of the switch before the switch is called. But now you can handle the null values directly in it. And if you want to have a default, but I wouldn't recommend that neither, but you can also have this kind of stuff at the end of it. Okay? This case object O will take the rest, everything. And by the way, the compiler is able to see that it's not a reachable statement. I think this is the warning I have here. Duplicate branch in switch. Well, oh, yeah. Okay, I see why. But if you want to have some kind of default stuff, you can, if you really need that, you can also implement it in that way and get the object you need. And it also supports, I'm not going to do that. And it also supports, see if you, for instance, let me duplicate this and say, okay, I'm just going to use the square. If the edge is equal to 0, then I can return 0 directly without having to do any kind of computation. And I can also write my code like this one. Now, this end here has not the same status as the end I wrote in the instance of stuff. In the instance of stuff, it was really the end, the Boolean operator, that takes a Boolean operation on both sides, because that's how the Boolean operator is working. Here, I have a pattern on the right, a pattern on the left, and a Boolean expression on the right, and it's called a guarded pattern. Okay. In fact, this stuff is itself a pattern. And it's a special type of pattern called the guarded pattern. It only works, of course, with the AND operator, but the status of this AND operator is not the same as the Boolean AND operator. It's not exactly the same. Yeah? Yeah. No. 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 I need to have... There are two things that are not working. If I try to put this case before this one, then this case would be obviously shadowed by the previous one. So that's a compiler error. And if I try to have it in that way, you see, I still have this error telling me that the switch expression does not cover all the possibilities. Yeah. Sorry, yes, edge cannot be negative, right? But, but you're right, it's an integer. Okay, so I have the same compiler error here. So I need to end up in that way, taking all the squares that have not been covered by all the previous guarded patterns. Okay? Do you like it? Well, I love it. All right. And I think that's... I'm just going to show some more slides, because the rest of the code, I won't be able to show it because it doesn't work. So when you want to show code that doesn't work, you fall back on the compiler that never gives you any error, which is called PowerPoint. I would like to give you 2 words of warning. When you're going to move from Java, whatever version, to Java 17. And the first warning is that the finalized method from the object class is already been deprecated, has already been deprecated. So you should not put any code in your finalize method anymore. And that has been known for years, okay? George Bloch in Effective Java, like 15 years ago, already wrote something about that. In the first version of, first edition of Effective Java, do not put any code in finalize. If you need to close resources in your finalize, try to use the auto-closable stuff and the try with resources stuff. This is your best choice. And if you want to do some cleanup or things like that, like calling list.clear in a finalize method, don't do that. Because you do not know what thread is going to call that. And if you call list.clear, you will end up with race condition that can produce null pointer exceptions. So don't do it. Plus, you have security flaws if you do it. And the new stuff is that just 2 days ago, okay, 1st of November, it has been, well, it's still a candidate JEP, but it shows that there is some effort to really get rid of this. It's going to be, it should be deprecated for removal. Okay, so the goal is to remove that. Now, if you think it's a bad idea, I've got another argument for you. Okay, Mark Reinhold told, I've been looking forward to this one for a very long time. So I don't think that there will be any coming back from that state. Okay, finalization is a mechanism that brings many problems, and the plan is to remove it. So if you want to move to 17, at some point, check your objects, and if you have any kind of code in your finalize method, just get rid of this code. That's the first warning. The second warning is this one. All the constructors from the wrapper classes, integer, longs, float, double, etc., have been deprecated for removal for a long time, and the plan is to remove them. Okay, so if you are calling them, if you are calling these constructors, just use value of instead of them. That's the solution, and that works in the same way. And this is part of a project that I'm not going to talk to you about, which is the Valhalla project. Okay, Valhalla needs this to be removed. So if we want, and we want Valhalla to make it to the JDK, we need to get rid of this, and it will be done. Okay. So that's the two words of warning I wanted to give you in your effort to move from 8 or 11 to 17. All right. Yeah? Sorry? Yeah. The question is, can we have some bytecode generated by a Java 11 compiler and running to 17? And the answer is yes. Java is backward compatible. Even if you take code compiled 20 years ago, you can run it in a current JVM and it will work. Unless you are calling APIs that have been removed in 9, for instance. Okay, so that was pattern matching for switch with the proper value of pi. You can use var in patterns. Okay, and this is deconstruction. I didn't talk about deconstruction yet, so let me do that. No, this is not. Sorry. I didn't quite follow the. Yeah, this is the one. This is the one I wanted to show you. Okay, the next step in deconstruction is a JEP that is still a preview JEP, but that could make it to Java 18. So we could have it as a preview feature in 18, which is called record pattern matching. Okay, being able to say, oh, if O is an instance of record, okay, and pass the component of the record in the instance of directly. And then in that case, with an 8, are going to become binding variables in this pattern. Remember that I told you that when we had rectangle, this rectangle variable is called a binding variable. In fact, I can have more than one binding variable. And in that case, this is the case. It's called deconstruction. It's easy to, well, it's easy. It's easy to do with record because I know that a record is built on components. So that's fine to do that. There is no other way to create a record. So this will allow me to get the component of the record out of the record directly with pattern matching. And the plan is to do the same with array. The JEP is called record and array pattern matching. And unless it is split in two JEPs, which is a possibility, but it's not in a plan yet. It's not in a plan at all, I mean. We can write this kind of thing. If O is an instance of string, and this is an array, and this array is has a length 2, then I can do something with the components of this array. But I can also write it in that way, okay? Creating directly binding variable in the array, and do something like that, which is great. And I could nest my patterns to do this kind of thing. Now we have got an array of circles. Circle is a record created on the radius. And I'm also using var because I know that this radius is an integer or a float or whatever. So I can also do it in that way, which is awesome. I can do it also, I can use pattern record, record pattern matching in a switch, which will bring this kind of pattern. And by the way, I could also fix a value in a case for this square. For instance, having case square of 1, and then case square of int edge, and do some stuff with it. This is hopefully something we'll have in the future. And I can even have more stuff with the, this is the use of the var keyword as a syntactic sugar in my pattern. So I can do that also because I know that circle is created on 2 doubles, for instance. So this var keyword will be inferred to being a double. But if I don't need a radius, maybe I'll be able to use an underscore to say, oh, I only need the center, I don't need the radius. So this is a way to tell the compiler that you are not going to use this the second variable. Okay? And if you want to nest pattern a little further, one step further, instead of writing this code, which is possible, it would be nice to write this code, okay, saying that this is an instance of a circle that has been built on a point that has been built on an X and a Y. So here I'm nesting patterns. All right. Okay, this is nice. This is about deconstructing record. You understand why we talk about deconstruction, right? But deconstructing record, but sometimes you're creating your objects with plain constructors, and these classes are not records. And sometimes, even if they are records, you may be constructing them with factory methods. So what about that? Well, there are plans to address also objects that are created using factory method. For instance, this kind of thing. I could be writing this kind of code, right? And say, okay, now I'm saying that my shape has been created with this code, square, dot square, that's a factory method, doubled radius, and extract the radius from that. That's the next step. Okay? There's no JEP for that yet. There's nothing, but that's direction in which people want to take pattern matching. That would be really great, and that could work with other things than records. It could work for any kind of class. Okay? If I have a class that is called point, and I can create a point on an X and a Y, the idea is to say, okay, how could I create a deconstructor? This is not a method, this is not a constructor, this is really a new concept that I could add in a class. You see that the output here is int X, int Y. That's the output of this stuff, deconstructor. I don't know how to call it yet, all right? And the signature, which is not really signature, should be the same. So if a class has several constructors, more than one constructor, I could have more than one corresponding deconstructor to be able to deconstruct it. Now, there are syntactic stuff to solve it before being able to implement this. But once again, that's the direction. The second stuff would be binding variables, you see, which are the same. And we call that the external state description. Okay? And that would be nice because it would allow you to create defensive copies for that. And that's a little kind of the problem for records. You say, okay, I'm created on this X and Y, but what am I going to take? If it's the list that is mutable, I should be able to mutate that list from the outside, and I don't want to do that. So I need to have a mechanism to be able to expose this internal state to the outside with a defensive copy mechanism. And that would support overloading, of course. We could be able to do it with a match keyword, having this kind of stuff. Okay, if my circle variable matches circle var center var radius, and then I can use the binding variables automatically instead of calling the accessors, which could be nice. Okay, it could even support an else, either to throw an exception or to add default values to the binding variables. And in the documentation, in a white paper that described it, they called it an anonymous matcher. That could allow me to write this kind of code, okay, or to use nested pattern that is having match rectangle of point var x0, y0, and point var x1, y1. I could nest that to create another pattern. Some more examples. I have factory method to create maps. So if I mix my pattern matching with the use of constants, I could say, okay, if my map is an instance of a map that has been created with a mapping name, and this would check if map is indeed a map, if it has a key called name, and if it's the case, extract the value bound to this key in a variable called name, and the same for email. That's just one line of code that would save me from writing, I don't know, like 15, 20 lines of code, checking, do I have the key that is called name? Do I have a key that is called email? Are the values null or not? If the values are null, probably I don't want to do anything, and and end up returning name and email. There's a lot of code to write if you want to do things that are as simple as that when you think about it. Okay, and I would be able, those are two patterns, but what would be nice would be to be able to combine those two patterns into just one. So this AND Boolean stuff here, this AND Boolean operator, would have to be changed to some kind of other operator. Let me call it AND in that way, which is not any kind of final syntax whatsoever, of course. But that would take two patterns and combine them into just one pattern. So that would be one pattern. So that's a difference. Okay, this one is pattern distribution. And now if you move one step further, okay, that's some JSON code, obviously, created with a bunch of factory methods called all over the place. But if you can inverse those factory methods to create patterns from them, then you'll be able to write this kind of code. That's one pattern. All right? And you can see that you can bind the value associated with the, and I'm not going to go through all of it, but you get the idea, right? That's just one line of code. You still have your basically have your JSON code written in some kind of just little different way, and you just extract all the variables all over the place, just in one pass. And now you can imagine how tedious it would be to write the code that would do that. But that's just one pattern. And if one day we can still dream about it, but if you know C#, C# can write this kind of code, right? Create maps with what is called map literals. Okay? But if you can create maps in that way, then associating patterns in that way could become possible. Now we need two steps, map literals and then pattern matching for map literals. That's not in a close future, right? And you can see that there is even a nested pattern here, because the integer.toString say, okay, this string has been created with this factory method, so extract age, which is an int. So now my binding variables, first name, last name are strings of characters, but the age binding variable is an int, because I've used nested patterns. We are not there yet. Maybe we will never be there, but okay, it's still a possibility. So where are we exactly? What you saw is constant pattern, to check the operands with a constant value. This is, let me go back several slides. Well, whatever. Hang on. I can do that. This is what we did with the map. Where was it? Okay, I can't find it anymore. Never mind. Oh, it must be somewhere. Never mind. Okay, it was the map when you have map with mappings and the value of the key as a constant, and then the binding variable defining the value. So that's a constant pattern. Check the operand with the constant value. The type pattern is check the operand that has the right type, cast it, and then creates a variable. And then so I showed you pattern with deconstruction that uses the deconstructor. Pattern with a method, with var, and with the underscore type. Okay. Now there are languages that already have that. I like to quote Brian Guts. That say we don't want to be the first to include a feature because every feature we had will never be removed. So we better have it right in the first place. And that's why we have preview features. Use the preview features. Download the JDK 17. Check it. And if you have feedback, just provide it to the team. That's right. So where are we so far? We have pattern matching for instanceof as a final feature in 17. Pattern matching for switch is still a preview feature. We should have it for 21. That's in 2 years from now. It's not in a very long time. Record on array pattern matching are preview JEPs. So they could make it as a preview feature in 18 in March. All right. Match and literals further away in the future. Not even sure we'll have them. All right. I think we have 4 minutes for questions. Questions? Anyone? I know it's almost lunchtime and you've been held prisoner in this room for such a long time. Yeah, please. Louder, please. What would be the difficulties to move from 11 to 17? If you're already on 11, you should really have no difficulties. You may have warning popping up if you're using deprecated methods, the deprecated method I showed you, like deprecated constructors, sorry, and deprecated finalization. I'm not sure if they were already deprecated in 11. And if you're, now that you know that finalization has been deprecated for removal and that new integer also is deprecated for removal, when you're going through your code and you see that, just remove your code or change your integer with the integer.valueof, and that's it. But really, if you've already moved to 11, it means that you've already removed all the calls to the API that have been removed for between 9 and 11. So I don't see any kind of problem you should have, really. You just get much better performances thanks to the new garbage collectors that have been added to the JVM. Better performances in so many places. You'll have better performances when concatenating your strings of characters, for instance. I think that has been added between 11 and 17. Now strings use a different, it's called compact strings. Instead of having an array of chars, you have an array of bytes. And so if you're using a string of characters with just ASCII characters in them, you will save a factor of 2 of your memory consumption for your string of characters, which is great. And you leverage invoke dynamic to concatenate your string of characters, so you don't need to use string builders and this kind of ugly stuff anymore, which is great also. So yeah, go for it. Yeah? Yeah. The current concatenation of string is more performant than using string builders. Forget about string builders if you're using 17. I can't remember exactly when it was added to the JDK. But now the string concatenation is using invoke dynamic, and so there is really no point in using string builders anymore. So forget about refactoring your string concatenation with string builders because you're behind. No more questions? Okay, that's it. Have a nice end.